أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم السلام عليكم ورحمة الله. Welcome back, and today we have problem on frictional force. Let us read the problem and begin to solve it. They said a metal block of mass 4 kilogram is on a plane and the plane is inclined at an angle of 30 degrees to the horizontal. The block slides down the plane from raise and travels a distance of 1.0 meters in just 2.0 seconds. What is the frictional force between the block and the inclined plane when the block is sliding? Okay, to begin with, we have two kinds of frictional force. The first one is kinetic friction when the object is at rest. If the object is at rest, let's say this is the object is at rest, okay, like this, there is no frictional force at all. But when I begin to push it, okay, then frictional force will exist in the opposite direction. If I'm pushing it in this direction, I'm pushing it in this direction, okay, if I begin to push it, there will be frictional force in the opposite direction trying to oppose the motion, and I must overcome this frictional force before it begins to move. That frictional force, we call it static frictional force, static or limiting frictional force. But when it is now moving, let's say I am pushing it, it is moving, then there exists another frictional force opposing the motion in the opposite direction, and it is called dynamic or kinetic, or you say sliding friction. Dynamic friction, kinetic friction, sliding friction, any one of these three is used and is correct. You can use it. Okay, how do we get that? First of all, if you have a problem like this in physics, try to translate the problem into a diagram to have a clear picture of the problem. And from the diagram, you can make so many deductions, okay? So I'm going to draw it. You have, what they are saying is you have an inclined plane. So if I have an inclined plane, look at it, and I'm going to draw this line to represent my plane. This is my inclined plane, and it is inclined at an angle of 30 degrees to the horizontal. So I draw something like this, and I say, okay, the angle it makes, I'm going to call this angle theta, and this angle from what we are given in the problem is 30 degrees. Look at it here, at an angle of 30 degrees to the horizontal. The horizontal is this one, this line, and this is our inclined plane. Now, our metal block, suppose the metal block is somewhere here. This is where I have the metal block. Let's say this is the center of gravity of the metal block. So gravitational force acts downward from that center, and I'm going to say, okay, this is my gravitational force. This one, and we know that it is mg. By gravitational force, I mean the weight of the object, and it is mg. This weight is like a resultant of two vectors. In other words, the weight mg has two components. One is parallel to the plane here, and the other one is perpendicular to the plane. So we can draw that here. We can draw that here. One is here, and its magnitude is mg, meaning this one multiplied by cos theta. The theta is the angle here, and the angle you have here is identical to the angle that you have here. So this one is let me draw the other one before I turn it. Then the other component of weight is along here. You see that is along here, and it is mg sine theta. Okay, it's mg sine theta. Now let me turn it, and you will see that it's a resultant force. You can see that if I turn it like this, you see this is vertical, this is horizontal, and this is the resultant of these two. You see, so according to what we learned in the class, the horizontal is mg cos theta and the vertical is mg sin theta. Now if you turn it back, see what you have here. So what I'm going to say here is that if this object is sliding down, there exists a sliding friction in the opposite direction, and it exists between the two surfaces in contact here. The black surface and the plane surface are in contact here, so the frictional force exists in this direction from there, and we can call it F sub R. We can call it F sub R. Great. Now, a force that opposes motion is usually given a negative sign, so we consider this force negative, and this force is in the direction of motion, so we will consider it as positive. If the block covers a distance along here, it is due to the influence of mg sin theta, not this one, not this one. Okay, we are not going to consider this and this. The significance of this one is that it is equal but opposite to the normal reaction. You have the normal reaction here, okay, R, okay. So this force here is equal to this, and the two cancel each other. So along here, or perpendicular to the plane, the forces cancel, okay. Their resultant is 0. So the only effective force I have now is along here, okay, parallel to the plane. As it is moving, don't forget it has an acceleration parallel to the plane. There is an acceleration in the direction of motion, and this acceleration is not given to me in the problem. Because it is not given to me, I have to find that acceleration, okay, before I can find the frictional force. How do I find this acceleration? I will check the problem. Maybe I am given additional information to help me calculate that unknown acceleration. They say the block slides down the plane from rest. You see the first information, they say from rest, and this from rest means the initial velocity is 0. V sub initial is 0. And then they say it travels a distance of, you see I'm giving the distance, so my s is 1.0 meters, and then the time taken to travel this distance is also given. Remember, I'm not giving final velocity, so this means I will use equations of uniformly accelerated motion, but I am going to ignore the one that has v. So the best equation to use here is s is equal to, meaning the distance covered, is equal to initial velocity multiplied by time taken plus half acceleration multiplied by the square of the time, and the acceleration is this one, okay, not gravitational acceleration, because we are considering the motion along the plane or parallel to the plane, not vertically here, okay. So we will not use g because g is vertical and this one is inclined. So let us make correct substitution. Our s from the problem is 1.0, and this is equal to v. It started from rest, so v is 0 times the time taken plus half. I don't know this a, so I'm going to keep it, and then multiplied by my time. I was told it's 2.0 seconds, so I will square it because the formula says I should square the second. You see the time 2.0 seconds. Now 0 times t is just 0, so it means this term will vanish. So on the left hand side I have 1.0 is equal to, on the right I have the, but how do I simplify this? I know I don't want to do it this way. I know that 1 upon 2 is 0.5, so you press 0.5 and then ignore this a, open bracket, just open bracket and say 2.0 close bracket and square it, something like this. Press something like this, and now press the equality sign. Look at what you have. Oh, sorry, I pressed it incorrectly. It should be 2.0 and not 20. 2.0 squared. You see, this means you press 1 upon 2. 1 upon 2 is 0.5. Ignore a, then open bracket 2.0 close bracket close and then square it. Now press equality sign. Look at what you have is 2. So it means you combine your 2 with A. This and this will produce 2, and then 2 times A is 2A. Next, divide both sides by this 2 you got. This cancel this, and then your A is equal to 1.0 is 1 upon 2, and 1 upon 2 is 0.5. And remember, this is acceleration. Its unit is meters per second squared. Now you got the acceleration. Now that you got the acceleration, the next thing for you to do is to apply Newton's second law of motion. According to, so I'm going to say from Newton's second law of motion, comma, according to Newton's second law of motion, that force is equal to ma. But do not forget that this force is a net force, meaning a resultant force. And the resultant force, how do we get the resultant force? Remember, I told you this one and this one cancel, they cancel each other. This is if you take this as positive and then this one as negative, because they are equal, this will cancel and you have 0. So the only forces you have are along here. Okay, so parallel to the plane, I have a force here and then I have a force here. So my resultant force will be, I will take the one that is positive minus this one. So it means my F net is mg sine theta minus F sub r is along here. Remember, we are not using this one because we already resolved it to this and this. So, and this goes with this, so we are using this one. So there is no point in taking mg. Okay, now is equal to, the whole of this is my F sub net, and then is equal to ma, where a is the acceleration I just calculated. Okay, the goal is to find my F sub r. So it is negative here, not positive. If it is positive here, I will just take this one to the other side so that it is now the subject here, but now it is negative. It should be the one to be taken to the other side, and then I take this one to this side, so I will have mg sine theta minus ma is equal to F sub r. If I do that, now I can now interchange all of them. So the left hand, the expression on the left, take it to the right. The expression on the right, take it to the left. So F sub r is equal to mg sine theta minus me. Oh, I got the formula. Now I have to make correct substitution. My m from the problem, they say 4 kilograms, so I will write 4 here and multiplied by g. Look at, they say take g as 9.81, so I will say 9.81 sine followed by sine theta, and my theta, you see, 30 degrees, so the angle is 30 degrees, minus m, again my m 4 kilograms, so 4, and then multiplied by a, and my a, I got the a here, 0.5. A is equal to 0.5, so I will now say 0.5. Finally, I bring my calculator and say, okay, 4 multiplied by 9.81 multiplied by sine 30 degrees, then minus 4 times 0.5. You see, minus 4 times 0.5. When after pressing all of this, now you press equality sign. You see, it is 17.62. So I will now write 17.62. Remember, what you are obtaining is frictional force. Because it is a force, it must be measured in Newton. So our frictional force, sliding one, okay, not static one, is 17.62. This is the end of our today's problem, and I hope you perfectly understand it. In case there is any point you begin to feel lost, let me see that on the comment section and I will clarify it for you. Assalamu alaikum wa rahmatullah.